So the next thing that we're talking about when we're talking about our descriptive statistics, or sort of basic statistics that we're going to use not only to describe a data set, but also later on when we're talking about inferential statistics, is the variance and the standard deviation. And I guess the first thing that we can talk about is that the variance and the standard deviation have this relationship with each other, and they're really the same thing. The variance is just the standard deviation squared. And you'll see as we learn how to calculate the standard deviation, we actually need to calculate the variance to get to the standard deviation. And that's because the nature of the standard deviation is that the standard deviation is a distance, right? The standard deviation is the average distance of all the points away from the mean in a data set. So let's hop on over to the iPad and we can sort of talk about just conceptually what we're talking about when we're talking about the variance and standard deviation. So on my iPad here, I'm going to go ahead and just make up a data set, right? And this data set is all going to just live on a number line that is centered at 0. And we're going to maybe say, we're just going to use blue for our data points. And we're going to make them just a little bit thicker. So we can say, if we have a number of data points, and I'm just making some random points here. This is obviously not a real data set by any means. Right? If I have some data set, right, each of these points, right, I guess the first thing that I might do is I might calculate the median, the mean, the 5-number summary of this data set to get an idea about what it represents, or the range of values that it can take, right? And let's say maybe that I calculated a mean, and it looks like to me that that mean would be somewhere right in this area, right? Now, what the variance is trying to do, the variance or the standard deviation is trying to come up with some sort of measure that measures the spread, right? Or how much variation there is in the data, right? So we're looking to see on average, right, how much spread there is in the data set, right? Or how spread out my data set actually is. So when we're looking at this spread or this variance, right, we get a sense of this from the 5-number summary, but it's pretty abstract at that point, right? It's not really very specific. So we can look at each of these individual points, right? And let's go ahead and say, if I'm going to call this is where my mean is at, if I have 0.1 here, right, and there's some distance, right, in between 0.1 and my mean. And if I were to do the same thing, for another point, right, again, there's some distance in between the mean and each of these points, right? And it's not exactly, right, it varies for each one, but what I'm going to try and do when I find the variance is I'm going to take all of these little lengths, I'm going to add them together, and then I'm going to find what the average distance away from this mean is. And what that is going to tell me is, on average, how spread out is my data set, right? How far away from the mean is the average data point, right? What's the average distance away from the mean for all my data points, right? So let's go ahead and let's again just kind of continue making up a data set, and I'm just gonna, for the sake of simplicity, use a bunch of integers here. And we're going to do just one of these by hand, and after we do that, then what we're going to do is we're going to switch over into code, right? So the first thing that I'm going to need to do is I'm going to need to find a mean. So I have 1, 2, 4, 6, 8, 11, 14, 17, 24, 28, 33, 38, 44, right? So I can just say the sum of this is equal to 44. Right? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right? So 44 over 14 is my is my mean, right? So if I wanted to calculate the distance from each one of these, right, what I'm going to have to do, I'm going to start at my first data point, right? And from that data point, I'm going to subtract the mean, right? And maybe just for the sake of keeping things into similar terms, I'm going to say that I have 14 over 14 minus 44 over 14, right? And that's going to give me some value. That's going to give me 30 over 14, negative 30 over 14, right? So this is, right, if I were to look at this in terms of my diagram, right, I'm looking at my smallest data set. This is one of the largest distances from the mean, and we can actually see that this is in the negative direction, right? So when we have this distance in the negative direction, this negative 30 over 14, right, if I were to do this for all of my data points, what would actually end up happening is the sum of all of these differences would end up being 0. That's actually what the mean exactly is. So, you know, having this in terms of a negative doesn't really help me. This is negative. How can we make it positive? Right? And sort of the most common trick that a mathematician will use to make something positive will be first to square it, right? And then immediately take the square root of it, right? And maybe just to have some more simple numbers to work with, right? Let's say I had a mean that was equal to 3 and a data point that was equal to 1, right? So I did, right? I had 1 minus 3 to find the difference between those two. You know, that's negative 2. But I'm going to square this, right? After I square it, that gives me 4. But then I take the square root of 4, and that gives me 2, right? And now I have a positive value of the same magnitude, right? And this helps me out because when we talk about distance, we're always going to talk about distance in terms of the positive. So when we're talking about distance in terms of the positive, right? No one ever drives negative 48 miles if they're going west instead of east or south instead of north, right? We always talk about distance in terms of positive numbers. So that's why we're going to square this. But if we were to continue on with this, right, I would have 14 over 14 minus 44 over 14 squared plus, then I have that same thing again for my next value. Right, and I'm actually just going to jump up here and get rid of this just so we're not crowded, right? My next 3 data points, right, it looks like are 2, so that would be 28 over 14 minus 44 over 14 squared, right? And I would go ahead and do this all the way through my data set. In the end, I would have, what is 6 times 14? I'm not sure. We'll just leave it as it is, right? So, in the end, I have all of these squared differences. I subtract the mean from each of these data points. I square those differences, take the sum of the squared differences, and then the last thing that's left is I'm looking for an average, right? So I'm going to divide by the number of elements that I have, right? The number of squared differences that I've taken, which in this case is 14, right? So if we were to sort of generalize this with the summation, what we're doing is we're going from I equals 1 to I equals n, where we have x sub I, that's a data point, minus x bar, that's the average from a data set, squared, right? And then after we've made that summation, we are dividing by n, right? And what this is this is our generalized formula for the variance, right? And you might be saying, Lance, you took a square root after you took that square earlier. How come you're not doing that again? And as it turns out, if I were to go ahead and take that square root, x sub I minus x bar squared, right? If I were to take that square root of those, then this is actually my standard deviation, right? So this is actually in terms of a distance, right? So the variance is not very intuitive, right? This comes out in terms of whatever the units that you started with squared, right? So if I was talking about number of cylinders in a car, I guess there probably aren't very many 3 and 5 cylinder cars, but that's okay. If I were talking about number of cylinders in a car, to say that my, variance is maybe 16, I'm not sure what it would actually be. 16 cylinder square doesn't make a lot of sense, right? Or it might actually be closer to like 3 or 4 cylinders squared, right? But if I take the square root of that, right, as I have here, then we get back into our original unit, right? And in our original units, I could say, now my standard deviation is 2 cylinders, right? So maybe the average car has 3 cylinders, give or take 2, right? And that's the standard deviation sort of as a distance, right? Now, I always like to sort of drive home this distance calculation by thinking back to when we were in maybe trigonometry or geometry, right? When we learned about this right triangle, right? And we had A and we had B and C, and we were always told, right, if we wanted to find the distance of C, right, that A squared plus B squared was equal to C squared, right? So if we think about the distance of A, right, what that distance of A is really is, if we call this 2, right, that's 2 minus 0, right? Because this is 0, 0, and this is 2, 0, right? So the difference on the x-axis is 2 minus 0, right? And we're going to square that. And then we have the distance between 2, 0, and we'll call this 2, 2, right? Again, the difference between on the y-axis, 0 and 2, again, 2 minus 0 is 2, right? So we have 4 plus 4, right, is equal to 8, right? And then we take the square root of that 8 and we say that is equal to our distance c, right? Hopefully you can see that, right? If we take the square root of this, right, distance formula is of the same form, right, of the distance formula that we use to get our standard deviation, right? So hopefully this is something that's at least a little bit familiar to you. This type of distance calculation is something that you're going to do as a data scientist or a machine learning engineer a lot. So it's really important that you are able to really interpret the standard deviation as a distance. So that's it for this video. In the next video, we're going to talk a little bit about finding the standard deviation using Python, both from scratch and from modules. So I'll see you over there in that next video.